All right, thank you everyone, and thank you so much, Shazia, for the invitation. It's my pleasure to come here. Um, I've been to Brisbane many times, so it's not a new place for me, right? I'm surrounded by friends, but also a lot of new people. Um, I'm going to give a presentation here on exploring and analyzing change, the Janus project. When I decided on this talk, I did not know that I was going to give it in the Global Change Institute. So it's all about changes, right? So this is work that I have done with many colleagues, including Felix, who's right here in the audience. So if you have questions, ask him. All right. So changes are, constant, right? So, paraphrasing an old Greek philosopher, Heraclitus, um, I'm just paraphrasing, right? Everything changes over time, right? If you've read Heraclitus, he talks about a person stepping into a river. It's not the same person, it's not the same river. He has many things about that. Um, and it's obvious to all of us that attributes of entities change over time, right? People who know me can sort of recognize me here. I don't know how many of you can recognize me from 20 years ago, right? I have other pictures that might be even more unrecognizable. Um, but also over time, different entities may have the same attributes, right? So I was looking for people with the same name, and I chanced upon this person, sort of was born close to 30 years after I did, right? Um, and looking at change and looking at aspects that change are very critical. So this is essentially the basis of the Janus project. So Janus, if some of you may know, who knows what Janus is, who Janus is? Right? Shazia knows, Felix knows. So Janus is the Roman god of time, right? He's depicted with having two heads, one facing the past, one facing the future, right? And it's also about change, right? Because things change from the past to the future. So what you'll hear about today is sort of what we have started doing with the Janus project, with a focus on change. Of course, looking at this issue is a very philosophical issue. What Janus is doing is really looking at things involving changing data sets, right? Shazi's already talked about how important data is, right? So what we've been doing is looking at data that is changing over time. And there are many, many data sets that we have looked at, and you can think of your own, right? What kind of data sets exist, right? So I'll discuss in my talk some aspects of things like Wikipedia and DBLP, mainly because these are public data sets, right? But any of you who's from industry knows that we often build these large data warehouses, right? And these are streaming. Things change, right? You have data, you build models on the data, right? When the data changes, you want to make sure that your models are still good, right? Wasim here is concerned about sort of, is there a data drift? And so that if I build a model, right, and things change and my predictions become inaccurate, then of course things get messed up, right? What we'll hear about is some of the initial work that we have done in this area, right? There's a lot more interesting work to be done. Okay, so I'll start giving some examples of very interesting changes, right, that appear in data sets, in public data sets. Again, I'm using public data sets because all of you can play with it, right? And all the data sets and code that I'm going to talk about is available publicly on the Janus website, so you can use that as well. So when I was, maybe I'm revealing my age here, but when I was growing up in high school, I was taught there were 9 planets. Right? Okay, who remembers 9 planets? Okay, around 2006, right, they decided to remove, Pluto as a planet. Right? So what was the consequence of that? That if you look at the Wikipedia on site on Planet from 2008, right, Pluto doesn't appear anywhere. Right? Turns out that a little while later, they decided that Pluto can be called a dwarf planet. Right? The Wikipedia site from 2010 reflects that. Right? So you can see, for instance, there was no Pluto, things changed here. Well, a little later, right, it sort of got its own separate table because Pluto was not an isolated dwarf planet. There was a whole bunch of them that were discovered, right, outside the solar system. So they no longer are grouped under planets anymore. But also over time, things change, right? What used to be called, the named moons of a planet has changed to the confirmed moons of the planet. Right? For those of you who know databases, the schema changes. right? So if you think about tracking changes over time, right, you want to understand that things change in many ways, right? Of course, the values change, right? At some point in 2010, the number of named or confirmed moons of Jupiter was around 49, right? In 2017, it was 69, and if you look today, it's probably around 80. New things are being discovered all the time, and they get reflected in these changes. So you would agree that, when I go back to look at myself as a person, right? Looking at me at a static point of time is not the best way of understanding me, right? You really need to understand me holistically. And I would say that that's true of various kinds of data as well. Looking at just the most recent snapshot doesn't give you a history of how things have come here, and understanding things holistically about the past and looking at how things change in the future is a very important way of doing things, right? Another quick example, right? This is an info box in Wikipedia about somebody who was one of the early Mexican presidents, right? Benito Juarez, who was very responsible for, sort of evolving Mexico to where it is today. At an early point, it turned out that he was, shown as being a president of Mexico from 1858 to 1872. Right? Which is about right, but what it missed, right, which is what the change here shows, is that he became president. At some point, the post of the presidency was, sort of abolished, if you will, because a king took over, Maximilian I, right? And then subsequently, the office was reestablished. He became president again. Sort of knowing these changes tells you a little bit about the history of Mexico. Right? So looking at change gives you an idea of many, many dimensions, and hopefully we'll see through the talk, what kind of interesting issues arise. Okay? So people convinced already that, you need to look at change? Yeah, good. What's interesting is that changes that you see, right, can be surprising. So this little plot was created by looking at the changes in Wikipedia info boxes for everything involving a variety of settlements. Settlements include, if you think of it, cities, right? The info box consists of a lot of different attributes, right? Who would have thought, right? Let me ask a show of hands, that the most common changing attribute in the info box for settlement would be name. You would think that name is something that should be reasonably stable. Because now I cannot show you what all the changing names are, because some of this is due to vandalism, and I can't show the names in a family-friendly audience, right? But there are changes, real changes that are expressed as well, right? Of course, you expect that, let's say the images change, right? The population changes, right? These are things that change naturally, but, the name changing, how many changes are there in the postal code? These are all very interesting things. Of course, you can ask the question, why did it change? And that's part of what the project is about, right? Supporting the mechanism for you to explore the data as humans so that you can sort of explore and understand why things change. So I'll give you an example of that a little later. Okay. There are many, many potential use cases once you talk about change. So before I talk about some of these are all data-centric, right? Shazia talked about resilience, right? If you look at the definition of resilience that Shazia put up, it was about being robust to things like errors, data quality issues. I would say a very fundamental aspect of being resilient is to be resilient to change, right? Data changes, the schema changes, right? So much of the information that we know changes, but you have a variety of applications, a variety of programs that are set up, right? And you want to be resilient to change, not just things that are wrong. Right? Would you agree, Shazia? So, you can be resilient to change by trying to understand what things are stable, right? What things change dramatically, and how do you have to deal with it? You can improve data quality because there's a lot of missing information out there. Combining information can help you improve the data quality of things out there. Trust is very important, right? One of the big things that happens in data that is publicly revealed, not just in Wikipedia, think of how much data was shown around the COVID-19, right? How much misinformation was out there, right? Trusting what information exists, right? is something which is very, very critical. Well, analyzing change can help you get better understanding of what you should trust and what you shouldn't trust. Right? Let me give you an example. You see a Wikipedia info box, a table, right? You know that things can change, right? I've already shown you examples of that. But if you see some piece of information that has been relatively stable for a few months, let's say, versus something that you know has been changing back and forth, right, over the past week, which would you rather trust? The first one, which has been relatively stable for 2 months, right? Or something that has been changing back and forth every single day. Who wants to trust the second one more? Come on. Shazi would like to trust the second one too, right? And the point is you need to understand why, because there are some things that do change every day, right? And for that, for instance, you might want to know that in fact, if it's been changing over a continuous period of time, it's okay, right? While something that ought to change, if it's been stable for a while, maybe it's just out of date, right? But this you can get when you explore the data. You should not just assume that stability means more trustworthy necessarily. Okay. All right, so what I'm going to do in the rest of the talk, right, it's in 4 parts right now. Okay, and I'll try to spend about 10 minutes on each part, right? And the first is about giving you an idea of how exploring change helps. Right? The idea is that when you see changes, really you want to keep the human in the loop. Right? You want to give the human the ability to look at the data, explore the data, and sort of understand why questions. Right? Answer why questions. The second part is giving you an idea of, let's do some analysis, right? The title of the talk was Exploring and Analyzing Change. So we looked at a lot of tables on Wikipedia to understand how things change. I've already given you a few examples, right? But looking at things in a more holistic fashion. And the last 2 parts are more technical things, because fundamental to understanding change is also asking, how do I track change? How do I know it's the same person, right? Remember there were all these Divesh Srivastavas floating around, right? How do I know it's the same person? If I'm looking at information that, the moons of a particular planet have changed, right? Given that something was called named moons and something else called, discovered moons or confirmed moons, how do I know the values are the same, right? So tracking change is very important, right? So it's in 2 parts that I'll talk about. How do I know when 2 tables at 2 different points in different Wikipedia pages really are referring to the evolution of the same table? And the second is, once I know we are in the same table, how do I identify entities, right? So in data sets, you identify entities through their keys, right? In databases, these keys are specified, right? How do you discover these keys in sort of Wikipedia tables and information which is changing in general? So I'll talk about that, but keep in mind that there are a lot of interesting use cases, a lot of applications. Let me give you a couple of things just to start off with. I talked about things like data drift, right? Now we know, for instance, that there's a lot of machine learning, right? I know a lot of you are interested in machine learning, which is what I want to give a couple of quick examples of those kinds, right? A lot of machine learning things like, some of the foundation models, GPT-3, others, are learning from existing documents out there. What do people know? That the learning that we are, doing is resulting in a lot of biased outcomes, a lot of fairness issues, right? If you learn from a static snapshot, right, and you find fairness issues, bias issues, well, maybe if you look at the history of changes and can figure out how things are trending, how things are tracking, right, then maybe you can sort of come up with predictions that take the direction and the velocity of change into account to result in things that are less biased, more fair for everybody. Okay. Let me give you another example. As statisticians, or as machine learning people who study statistics, you all care about the difference between correlation and causation, right? So without putting people on a spot, I remember at VLDB in Sydney recently, we all heard a talk from a well-known DEI researcher who mentioned that, companies that have more women on their boards, right, tend to have a higher profit. right, have 43% higher profit. I'm making up the number, right? There's probably a different number. Now, the point is we don't know, is this just correlation or is this causation, right? If you look at a static snapshot, there's almost no way to figure it out. Right? If you look at changes, right? If you look, for instance, at what was, the composition of the board today over the next 5 years, right? As people add women to the board, is their profitability going faster in general on the average than boards that don't? Right? You can better get a grip of things like that from changing data. So hopefully, you see that what I'm going to talk about, right, is a part of it, but hopefully what you take away from this talk is changes are important, right? And every single thing that you do, whether it's in databases, whether it's in data mining, whether it's in machine learning, right, can be improved if you think of changes as first-class citizens, not something that just happens along the way to get you to a static snapshot. Okay? So we developed one of the early tools was something called as Database Change Explorer, DBChecks, right? The idea was that looking at a data set, you want to be able to allow people to explore these changes, right, in an interactive, effective fashion. Well, when you have a lot of different data with a lot of different schema and you want to build tools that can help people explore change, a simple way to do things first is to make sure that all the data is represented in a way, right, that the tools can work with. So all of you are familiar with, for instance, what people did with things like RDF, right? Or try to just think of them as subject, property, value triples. But change, you add a dimension of time, right? So we talked about the change cube where different sources could be transformed into a change cube, which just consists of 4 things. When did a change happen? Right? To what entity did that change happen? What property changed and how was that value changed? Right? You can collect information from all changes in this representation and then sort of be able to do some kind of exploration. Of course, a very good question is, why did things change? So you want exploration to do that. Right? By the way, I didn't quite mention it, but if anybody has any question that you want to raise, just ask. Right? Otherwise, you might run into the risk that I'll ask you questions too. Okay, so I'm going to give you a quick example of change. How many people here have used DBLP? Hopefully most of you, all of you, right? If you look at DBLP, again, we look at the most recent static snapshot of DBLP. Most of us don't think about the history of all the changes. But as part of this project, we got the entire edit history of DBLP, a lot of different changes happening. Right, so let me give you an example. So this is something you might be able to do using the kind of tools that we have built, right? So if you look at, how many updates, right, happen in DBLP. So updates are things, where you're changing some information about a newly created record, right? You might look at this and say, hey, look at this early era here. This seems to be a big blip here, right? Why did that happen? Why did so many updates happen, let's say, at that time? Right? Turns out that when you explore and ask which properties of different entities changed around that time, look at the number, it's about close to 30,000, 29,000, something around that time, right? It turns out that at that time, about 28,000 different articles had their journal property changed. You explore why, and it turns out, okay, this is partly conjecture, that DBLP started around 99, right? In a few years, DBLP became sufficiently successful that the publishers, ACM, IEEE, and others, these publishers wanted to make sure that the way the journals were represented, were named in DBLP, was consistent with the way the publishers wanted them named. Right? So things like CACM became communications.acm, right? This is the way ACM likes to refer to its journals. This is what they do on the ACM digital library, right? And so on with other things. So they went ahead and made all these huge number of changes, right? And now you can sort of understand why this is important. Well, how does it help you? Imagine that you had set up a script earlier to tell you from DBLP whenever a CACM paper appeared. Okay, they made this change, and suddenly after that, there were no more CACM papers. Right? Well, because they're all called communication, so they assume, right? You often need to sort of make sure things are resilient by exploring change and making the right changes to reflect those things as well. So in these kinds of things, we created a tool, of course, right? So what you can see is a quick video of how the tool is working. Somebody is looking at these 4 tuples, right, involving things with, the what, the properties, the value, and the timestamps. Maybe they look at things and say, here are all the values you have, right? There's a lot of them out there. These are the top 10. But maybe somebody is interested in something different, looking at things that maybe they're interested in Monterey, right? So they try to find, in this exploration tool, something that sort of matches Monterey, and they find that it results in a lot of different matches, right? Maybe they look at all of these things and they want to explore something about Monterey, California, right? So you can see how things go in steps here. Well, if you want to understand things and you see a lot of different properties that change, well, you want to sort of split up and say, which properties changed more often? Let me explore that. And you find suddenly these are the properties and these are the number of changes that happen with respect to these properties. Okay, now you want to understand for a specific property, what were the values? When did they change, right? So these are all the kinds of things that the DB Change Explorer allows, right? In this case, for instance, you see how the value for things, right, changed from a Monterey beach scene to a wharf, right? That was the way the image changed, right? So rather than go through all of this, right, I want to give you the idea that, these kind of change exploration tools helps you explore changes in the data and get a better understanding of why changes happened. Another tool we built was to show you that, okay, if you look at this static Wikipedia page, looking at things like trust and changes, right? This doesn't give you enough of a sense, but imagine if this could be overlaid by something that looks like this, right? Where you show pretty much the same information, but the color coding tells you a little bit about what things were more stable, what things changed more, right? And also gives you a timeline of when things changed, right? Wouldn't that be a lot more helpful to you, right? Of course.
People consuming information are already overloaded with the current reflection of what's happening, and that's the consequences of historical changes. So how do they deal with this added dimension of past histories or changes that have already resulted today? So that additional dimension of it, how do you make use of it?
So very good question. So let me try to answer it in a different way. Sometimes more information can help you prune things, prioritize things, and look at things that matter more to you, right? If you looked at that original table, it's not that big, but it's still a lot of information. If I give you this table, your eyes are, going towards focused pieces of information. You really care about stable information, so maybe it's only a part of it, right? Or you care about things that change a lot, maybe that's only a part of it, right? So giving you the right additional information can help you address the information overload, right? By making that not everything is equal, right? You don't need to look at everything and understand everything. You can focus on a few things. You can prioritize it, right? And this is one way of prioritizing. Maybe there are other ways of prioritizing as well that you can. Does that help?
Still digesting, but
Sure.
yes, it does.
Sure. Okay. So I've given you an idea of how you could explore change, right? I want to give you a quick idea of, in fact, not only things change, but let's say Wikipedia, right, is such a huge resource for everybody, right? It's not just computer science, but Wikipedia has information about every single discipline, right? All the different disciplines people talked about, life sciences, business, everything, they have Wikipedia pages about it, right? So understanding how the information changes can help you gain a lot of information. So we spent some time just looking at changes in Wikipedia tables as an example of certain kinds of analysis one could do, with these tables. So let me start with, a simple question. When people read Wikipedia pages, have you noticed how many tables are there on Wikipedia pages? Who thinks that Wikipedia pages typically have 1 or 2 tables on them? Right? Who thinks Wikipedia tables could have hundreds of tables on them? Hundreds. Okay, all right. Okay, so of course you have seen changes, right? So this is the information about the corpus that we analyze. You don't need to go into in detail. The most interesting thing for me here is this graph, right? So if you look at this graph, what this is saying is it's the number of new tables and Wikipedia pages that have been created over time. So this lighter one is about pages. What you notice is that starting early on, right, the number of pages that were being created grew rapidly, right, peaked around 2010, right, and now the number of new pages being created is actually dropping, right. Over the same period of time, right, the number of tables that were being created, right, on a regular basis kept increasing, but it did not see a drop, right. You continue to create new tables, right. We'll look at things that have all change, but now people are adding more structured information to these pages, right, distilling information that ought to be created in a more structured form. Okay. Okay, so I'm going to sort of look at this as a table life cycle and try to convince you that just as humans change, people are, sentient beings. Well, maybe we should think about tables and structured information as also having a life of their own, right? And as a life of their own, they create, they, sort of evolve, they die. Let's understand this, right? So in terms of creation, asked a question, it turns out only about less than 20% of all tables in Wikipedia appear alone on a Wikipedia page. 80% of them have multiple other tables out there. Okay, for a variety of reasons, right? The author's preference, some information is more suitable for tables. I'll show you examples of these, right? If you look at any city, right, pick your favorite city, I don't know, Chicago, look at how many different tables are out there. But what is interesting is you can see here is the number of pages that have only one table is about 20%, but there are all the way down to pages that have hundreds of tables, even 1,000 tables on the same Wikipedia page. Okay. To give you examples, here are a couple of tables or a couple of pages that have hundreds of tables on them. You can, if you have web access, you can look it up right now. Right? What kind of information is here? Who creates these tables? Right? Is it something which is done in some kind of a democratic fashion? Does everybody do this? No, it turns out that there are power users who create a lot of tables out there. Right? More than half the tables out there in Wikipedia have been created by users who have also created at least 128 other tables. Okay, what this means, of course, to understand is it takes skill to create these tables. So while you might think that people who can edit Wikipedia text pages are a lot more, right? People can go in and quickly edit things. Doing something with tables today requires more effort. So it's the people who are the dedicated users who have the skills to do so, create that. Why is that important? If somebody wants to say, I want to identify a random sample of tables from a random collection of users, be aware that just picking tables randomly doesn't mean you get a random set of users. Okay, it's very likely to sort of be influenced by those power users. As an example, here is a particular power user who is responsible for more than 10,000 tables. Right? You can see a lot of these are music tables, right? All related in some way. This person really cares about it and has created thousands of tables. There are lots of other such users. And it's not just a user who sort of shares things. There's a lot of information, for instance. It's the same kind of schema that people start off with, the same gene pool to create a lot of tables, right? The use of copy paste is natural. Creating a table is difficult, so if somebody wants, they take a table from somewhere, use the same schema, maybe make a few changes, and then work with that. Right? So here's a simple example of a baseball template. I don't know how many of you follow baseball, but think football, think, any kind of thing, right? People start with a particular schema, and then suddenly you have many users who do this, right, and create lots and lots of tables of that kind. This is how information gets created, right? Structured information gets created in Wikipedia, right? Some of you are probably old enough, like me, to remember that when people built early models of the web, and they talked about how people created web pages, that was also a model, right? That people took an existing page from somewhere with the links, copy it, and make a few changes, right? That's one of the reasons why the whole model of hyperlinks and how the structure of the hyperlinks work. It was not random, it had a certain structure to them. Okay, in terms of how things change, okay, here's a very interesting thing, right? We've talked about tables as having a life of their own. So let's have the society. Things change and age quickly. So this is an example of something. Says if I look at the tables that existed around 2019, was it, Felix? Right, there are about 2.5 million, 2.4 million tables out here, right? If I look at these 2.4 million tables and go back in time, right, and ask the question at a given point in time, how many of the tables in 2019 existed, did not exist, changed, updated, right? That's what this graph shows you. So let's look at these tables in 2019, go back in 2015, and said of the tables in 2019, 1 million tables did not exist in 2015. If you go further back in 2010, right, at that point maybe 1.8 million tables did not exist. Right, of the tables in 2019, right, only about 600K, this light green portion, have been unchanged from this point in time. Right, about 800K tables have been changed in the meanwhile. That gives you an idea of the extent of these changes. Things get created, significantly altered, right? But also some of these tables that existed in 2015, about 200,000 of them have been deleted. Right? So those have been deleted in by 2019, right? So things get changed, things modify, things die as well, right? The schemas change over time. You can start with a bunch of tables with the same schema, things evolve, right? We know there are people who create these tables. Are they responsible for their children tables, right? The ones they created? It turns out that if you look at tables and how many editors they have, well, a large number of tables, the most of them have a single editor, right? The one who created that table. But there are tables with a large number of editors as well, right? So there are tables with thousands of editors. But if you look at this and ask the question, when do people make these changes? Early on, right, when the table is young, if you will, most of the changes are by the creator. Right? As the table gets older, you have more and more changes being done by people who are different, other editors, right? Again, not that different from society, right? Most of us do most of our things for our children at their early age. Over time, others sort of step in as well, right? Of course, tables die, right? But a significant number of tables that have ever been created continue to exist today, right? And if a table is deleted, dies, it usually happens very early on in its life cycle. Okay, again, not that different from people as well, right? So, hopefully, what I've shown you is sort of an understanding at sort of a very high level of how much things change, right? So, if you want to be resilient to change, you know how careful you have to be, how much work you have to put in. Right? If you build models based on the data, be aware that things change, and things change in a way that might result in data drift, right? That you have to make sure you evolve your model. But at the same time, right, from the machine learning perspective, don't just imagine that any time things change, you have to change the model, because there's a lot of data quality issues here as well. I'm sure all of you know there's a lot of vandalism that goes on the web. Right? If you respond to every change and try to fit your model to the changes, maybe you're sort of capturing the data quality, the vandalism, and that's non-trivial as well. Okay. So how much time do I have, Shazia? Okay. So I'll quickly tell you a little bit about how we can try to track changes, right? So you want to do structured object matching. Think of it in two parts. Right? I've already told you that on a given page, there can be a lot of tables, and these tables change. Right? So if if you remember, from databases, a table has a name, right? In the SQL schema, right? If you make changes, you know the name of the table is the same, so you have an idea of what the changes. Changes in Wikipedia on the web, tables don't have names, they don't have identities. Right? You have to look at the content to understand which table in version 1 corresponds to which version of a table in version 3, right? There are a lot of changes, right? I've shown you things involving info boxes, but tables, lists, everything's changed, right? But figuring out which tables sort of in an old version correspond to a new version is not trivial even for humans. So here is just an example. An early version of the Chicago page had this table for Chicago airports. A later version had this one, right? These are all Chicago airports. As humans, we look at them and say, it's the same kind of information, right? More airports have shown up because you're looking at a broader area. You have more information, but intuitively, it's the same thing. The reason in this case why there's so much difficulty is that this table was deleted in 2004. This one was inserted in 2010. And in the middle, there was no change, no information, no table about airports. Right? So you have to sort of look at these things, not just in every consecutive thing. A lot of interesting things happen when you want to do evolution tracking. Things can disappear for a while, reappear. Is that just a delete and something new? Or do you want to keep track of it as the same thing? Because then the lineage of it goes back longer than time. Right? If I want to match by simply looking at the position of a table on the web, it doesn't work. Just look at this position, the first position, and think of over time which kind of table from this large collection of tables on the Chicago page were in the same position, and of course, almost none of them were. Right? You do see some stability here. This was in first position. At some point, this green table appears, so this got pushed to the second, got pushed to the third, and so on. Right? So if I want to be able to do this kind of matching, there are a lot of interesting challenges, right? These tables are small, so the amount of content is not that much, right? It's shrinking, growing, the layout changes, there are short-lived changes. Given all of this, how do I track changes, right? So we have a particular approach for doing this kind of matching across versions by looking at the content. And I don't know, Felix, we also looked at a little bit of the context around the table as well, right? In order to understand, what is the text or the things that people sort of have around the table to understand which things might be the same, right? So the goal here is, let's say, having looked at a certain collection of versions of tables and knowing which ones match which ones. This one matched here, this one disappeared, this one only appeared here, right? And you see a bunch of tables in a new version. Which of these ought to get matched, right? Maybe this is the final matching you want, right? But there is a multi-stage process to do that matching. Again, I don't need to go through the exact process to do that, right? The approach that we found worked the best in practice was to start with, at the core of it, there is some kind of a bipartite matching that's done, okay? But keep in mind that bipartite matching is not always what you need, because sometimes the similarities are too low. So it might be, a new table gets created, old tables get deleted, right? At the same time, if you want to do this at scale, trying to do bipartite matching all the time can take a lot of time. So you want to be able to do certain things that are greedy as well. So our approach, for instance, is something to say, let's start with something which has very high quality matches, right? High similarity. Let's match them, right? Then for the rest of the things that are remaining, modular subject to a certain threshold of similarity, let's do a bipartite matching. Which one sort of gives you the best overall score, right? Some of you know how this bipartite matching works. If you don't, come talk to me later. Happy to talk more about it. Okay, and then finally, you might decide that you have certain kinds of weak matches, and you have to decide, do you want to preserve things with a longer table history? Do you want to think of it as, okay, this is an old table got deleted, something new got created, right? So there are, in this case, some subjective decisions as well. Okay? Not everything is completely objective. We did some evaluation to show that the approaches that we have result in much higher quality matches. There are a variety of other approaches which might just be based on the position or the schema, right, or prior techniques to be able to do this matching, right? And the techniques that we have are not just for Wikipedia tables. You can apply them to general web tables. You can apply them to data lakes, right? And the quality of our matching approaches over time, looking at these kind of matches, still is, the best that we have seen, and very high quality matches in general. So I have 5 minutes, right? So I'm going to just quickly tell you that, once you've identified tables that match, how do we identify entities in those tables that might persist, right? Okay, in the philosophical sense, in Heraclitus' terms, it's very difficult, right? Because we don't know which properties persist over time, because I just told you everything can change over time, right? But when we start to represent things in data sets, we often like to have certain kinds of keys, right? In real databases, we use surrogate keys, things that get created explicitly for the purpose of linking and preserving identity over time. If you have seen, there are no such surrogate keys in these kind of changing databases which are publicly edited. Okay, so the idea that we had was to sort of discover what we refer to as natural keys, right, which are unique keys that exist in the database, right, forming in terms of attributes that exist and are used, right, and things that hopefully can persist over time as well. So for instance, in this page, right, maybe this is a particular thing about a bunch of different sort of, what were these, right? Maybe these were movies, right? At some point, given distributors and their worldwide gross, things change over time. You would rather assume that this title is the key, right? Even though from the table perspective, maybe the rank looks like a particularly fine, unique attribute, but you don't want to refer to the rank as a key, because then you might think, right, it's that entity, right, that keeps changing because maybe the position of the different movies will change. How do you discover these natural keys? You want to take into account not just the static data, but you want to look at it temporally. If something is popular, things are being referred to the same way in multiple tables and multiple Wikipedia pages. You need to look at a spatial dimension as well, right? And so in the Wikipedia tables, for instance, sometimes you have single column keys. Here, for instance, the combination of the year and the tournament. Think of natural keys as the way humans we naturally refer to something. Okay, we are referring to something as, I think Brisbane is going to have the 2032 Olympics, right? You're going to refer to it as the 2032 Olympics. That's the natural key, right? Calling it the Brisbane Olympics may work if it happens to be the only time Brisbane has hosted it, but there are cities that have hosted the Olympics more than once, right? Just referring it to it by the city name and may not have worked, right? So this is what you need to be able to discover. It turns out there are two kinds of natural keys, right? We have a Global Change Institute, so there's a global natural key as well, right? These are things which are keys which are referred to in the same way across multiple tables across time, right? But sometimes you also have things which are keys. For instance, in this particular page, which is of a particular Game of Thrones page, right? Just the season is a local key in that page, right? Because you have information about the seasons that changes, but the combination of the context, which is, let's say in this case, the page title, along with the local key, is enough to globally identify it, right? And this is how it may be referred to in other pages, right? The Game of Thrones season 3. Okay. So we have a technique, right, where we use machine learning approaches to automatically look at a set of candidate keys, right? Look at historical information and spatial information from other tables, identify a variety of features. I'll show you quickly what kind of features we use. We extract features, we train models, identify which ones are more likely, most likely, and those are the natural keys that we identify, right? So there's a large number of features, okay, not thousands of features, as may be true in unstructured text or certain kind of images, right? But a designed set of features which is sort of in the 25 or so range, and these features, right, could be information that are just local features from that column or the table, right? There could be temporal features, which is the behavior of that over time. Could be spatial features. Are there similar columns in other tables, right? And looking at these things, we also did an empirical evaluation, right, using our approach, right? And we used, given that there were only 25, 30 features, really we don't want to use deep learning models. It might end up in overfitting, right? So we use something which is a random forest model here. We compared with a variety of different techniques and essentially showed that our approach, looking at the local, the temporal, and the spatial features, actually ends up with the best results in being able to identify what are these natural keys. So this is early work on natural keys, right? We were the first to sort of officially define natural keys, look at it in this context, right? There's a lot more work to be done. You see this, the accuracy here is not in the 99%, right? There is scope to improve things. Right? So there's a lot more interesting work to be done. The experimental results showed that we have good results. We can do this in a very scalable fashion. But very importantly, what I would like to talk about is the fact that all of these data sets and all of the code that we've been talking about is available, which is really very useful for people to do follow-on research. Not just in this area, but if you want to sort of understand model building using some of these Wikipedia, you can do that as well. Right. So let me end with the fact that we have this project page. We started this work, right, with a vision paper in VLDB, right? Exploring change. This was the vision paper that we had, right? And we identified many different challenges that we need to address, right? I would say that we have started scratching the surface of some of them, but by no means we have, completed anything huge, right? There's a lot of work to be done. So I encourage people in this community here to think more seriously about change, do research in this area, and see what kind of ways in which this can actually improve over what people have done before, right? It's Janus. This was our past. This is our future, right? And any questions? Any criticisms? Thank you very much. Happy to take questions now. I'm here all day today, right? Catch me in the break, ask me questions, right? Happy Adho.
One question.
Yeah, Hector.
Yes, so far you have discussed the changes over tables, right? Well-structured data. So have you done some work on unstructured data and also multimodal data? Because for example,
We have done work in semi-structured data. So if you think of lists and to some extent the way info boxes are structured, it's a little bit semi-structured. There is separate work that I have done on changes that try to match text data in Wikipedia pages with changes that happen in the tables. So trying to match how changes in the text and changes in the structured data reflect each other. Sometimes some of them get delayed, right? Sometimes you make changes in the text and it's only a few days later that the change shows up in the structured data or other things, right? So looking at these things, how things evolve, I have done. But we have not done anything in multimodal data in the true sense of multimodal data. There's a lot of work to be done.
yeah, for example, one page, one web page
Uh-huh.
may have table,
Uh-huh.
may have description,
Yes.
may have image or even video.
Yes.
Right? So those changes may be.
Absolutely. So we have not done any image analysis, but to the extent that you want to be able to co-analyze unstructured text and structured data, there is some work that we have done in that space.
Very good. Thank you, Heng Tao. And questions from the students? Yes, go ahead.
So how do you address if, for example, someone has a surname, but it's in different language and different alphabet, and it might sound or type differently sometimes, and the surname might change. Like someone can request, okay, change my surname, and how do you know that it's the same person?
I don't.
So there's a
Right, so this is part of what you want to be able to do with change analysis, right? So if you discover, for instance, so this is not that uncommon, by the way. I don't know exactly when it happened, but I know at some point the Greek government in Greece decided to formally introduce a way to write Greek names in English, right? And it formalized that, and a lot of people had to change their last names to reflect that. Okay, so if it's one isolated change, right, you might think somebody changed their last name. If you have a lot of information about Greeks and you do your analysis and find that suddenly, over a small period of time, right, all the Greeks seem to have changed their name, well, okay, you suspect that something else might be going on, right? So that human interaction to understand why did things change is why we have these tools, right? I don't believe that everything involving change and change analysis can be done purely in an automated fashion. So this is one example where some human insight is very important as well. Yes, sir.
So you use very volatile sources, right? Like Wikipedia. Is there certain times where
So let me try it the other way around, which is there's a lot of industry data which changes substantially over time. Right? There's a huge amount of new data coming. Right? But there's a difference between data that is being appended, right? Sort of like streaming new data that is coming versus existing data that is seeing a lot of modifications. Now you can imagine, let's say, one of the earliest uses of databases was to manage banking transactions. Think of how many transactions happen in the stock market or the banks, right? So, things actually change. Your accounts get updated, right? It's volatile, right? And there are people, I'm sure, whose bank accounts and whose values of their stock portfolios change so frequently, right? But volatility of that kind may be expected, right? So you have to think about what kinds of volatility are unexpected and therefore something that you have to question if it happens, versus something where the volatility is expected, and if it doesn't happen, then you have to question it. Right? But certainly, being able to analyze things that are changing fast is very much essential to industry. It doesn't help you if you're trying to, let's say, build a model, right, which is 3 months out of date because you realize that significant changes happened 3 months ago, and you're predicting something, which is really not what you ought to be predicting. Right? So being able to handle things in real time, right, when the changes are in real time, is actually a significant and an important direction that we have to think about, right, going forward. Right? It's another one of my research interest areas is looking at streaming analysis. Okay, my interest in time has spanned over time, should we say.
Can I add change is the only constant?
No, but yes, that's what
Okay.
people talk about, right? So.
All right, more questions.
I have a question about the similarity computation, because as you mentioned, it's like a five structured data. So you want to calculate the similarity between two instances. So how specifically you do that?
So for the table data that we did, right, we did something very simple. Because realizing that, across time, the schema can change, the layout can change, right? So many things can change that, trying to look at something, a structured notion of similarity by seeing how many rows are the same or how many columns are the same is, not necessarily the most robust, the most resilient thing we do. So we extracted all the content, think of it as a bag of tokens, right? And looked at similarity in terms of the bag of tokens by looking at something simple like Jacquard similarity. Right? But you can do more sophisticated things, right? If there are table headers, you can do something more sophisticated with them. I think we took the little bit of the context around the table, the actual words that appear, maybe the sentence that provides an introduction to the table, right? To look at the notions of similarity. But what is the right notion of similarity, right? And how that notion of similarity itself might change, right, is something worth thinking about as well. So I'll give you one example of something which I don't think we did, maybe Felix will correct me, right, is, people change the position of the table in the page, right? So sometimes maybe the text that surrounds the table provides some information, maybe sometimes the section heading, right, under which that table is located provides a little bit more context to that table, right? Taking all of those things into account might give you even better matching properties, right? More work to be done, interesting work to be done.